What's going on, guys? Chapter 6 notes here, ready to start Unit 2. Unit 2 is linear regression. So linear regression, before we even get to that, we have to understand what linear regression is all about by first talking about scatter plots and two variables and their associations. So you guys have probably heard these words before: scatter plots, associations, correlation. I believe you guys know what a scatter plot is, so let's just quickly draw some random scatter plot here. So scatter plot, when we have two quantities, an x quantity and a y quantity, and they have a relationship with each other, and we can describe that using words like association and correlation. So this scatter plot is a graph that shows a relationship between two quantitative variables. So a graph shows the relationship between two quantitative variables. Not categorical variables. We're not going to be dealing too much with categorical variables outside of that first unit. So one of the first checks to see if we can even use scatter plots is going to be, do we have quantitative variables? Remember, quantitative is something that you can actually count and measure. So we have an explanatory and a response variable. Think of this similar to independent, dependent. It really is synonymous, really can be used interchangeably. So explanatory, let's think of as x, and our response variables as y. So the explanatory variable in this case explains the response variable. So explanatory variable is x, and let's think of it as our independent value. And our response variable would be our dependent value. Oops. So remember, these two quantities have to be quantitative. Otherwise, we can't actually get a scatter plot. And we'll actually get into using your calculator and how to put these scatter plots on your calculator. Your calculator can actually do some really cool things. So we'll get into that stuff later in the chapter. So describing scatter plots. When describing scatter plots, we have three main things. First thing right here, as you'll see, is direction. Second thing is form. And if we scroll to the next page, we have something called strength. So, first thing, direction. With direction, if you can think of a line of best fit, remember for scatter plots, the line of best fit is kind of this imaginary line where we have an equal number of data points above and below that line, kind of right in the middle. And if we drew this imaginary line of best fit, whatever direction that line is going in, so either up or down, that's the direction. So in this case, since our line is going up, we say that this association is actually a positive association. And in that case, that means as x goes up, the y variable also goes up. As the explanatory variable goes up, so does the response variable. Now, this second picture over here, a different scatter plot, and if we were to imagine a line of best fit, that was actually kind of a bad line of best fit, maybe a little higher than that. There you go. If you can imagine that line, we can see that clearly the association is negative, and that means as these x values are increasing, going this way, we can see that the y values are decreasing. So as x goes up, y goes down. And if we were just to think about two actual quantities with context. As one variable goes up, the other goes down. Now, this last one over here, kind of weird. Scatter, no real association, it looks like. We can call this a cloud or a cluster of points. And we say this just has no direction. It's really hard to actually tell, is there any association, whether positive or negative, between those two variables. So that's direction. Direction, positive, negative, or no direction. Now the form. The form is going to be something that for the most part is going to be pretty easy to see. And for form, we're looking to see what shape best describes the association. So in this case, this very first one, this is what we want. We want scatter plots that have a linear association. These are good to work with. Whereas in these over here, this one, you can kind of tell has more of a curved pattern. For what we're going to do in later chapters, linear regression, these are not going to be easy to work with. We are going to have to do a couple extra things to take these scatter plots and actually make them useful. So for linear regression, which we'll get into in the next chapters, we want linear forms. This one will be curved, and this one is also curved. So direction and form. And the third thing we want to talk about is strength. Now notice these are the exact same three plots as the first three up here. So remember when we drew the line of best fit for this guy, we said that it had a positive direction. But now we can talk about the strength. Now when talking about the strength, if you can imagine this line of best fit, how close are each of these points to the line? The closer the points fall on the line, the stronger the association is. So in this case, for this specific example, we would actually say that this is a relatively strong association. So if we were actually describing the three things for this graph, the strength of this graph is pretty strong, the direction is positive, and the form is actually linear. All right, this second guy over here, let's see, it's also linear. I didn't draw a straight enough line there, but you can see it's pretty linear. This one is not positive because we can see the line is actually decreasing, the line of best fit here, so we would say this is a negative association. And then this one is not as strong as our first guy. So if you see with this second line, the cluster, the points are kind of further away from our line of best fit. So this one we wouldn't say is as strong. This one we would say is maybe moderately strong. Now, this guy over here, the last guy, I know that it has a curved relationship, but when we're talking about strength, we're not talking about anything besides lines. So if you actually want to add in a term over here right above strength, let's add the word linear. So we're actually talking about the linear strength. Does it resemble a line, straight line? So if I drew this line, this would be the line of best fit for this guy. You can see clearly here that this is not really a good linear relationship, right? We can see it's curved, it goes up then down. So we would say this is a weak association. All right, anything that's curved will be a weak linear association. So just recapping, we have direction, form, and strength. That's how we describe scatter plots, describe the association. And just like with other graphs, any unusual features are definitely something to talk about. So in this case, let's look at this first graph. And if there's one thing that kind of sticks out, I'm going to circle it right here. If I drew a line of best fit, all right, so here's the line. We can see it has a positive association. It's going up. I would say this is moderately strong, and it does have a linear relationship, right? And we can see that the line of best fit is a straight line. But this guy over here, a little weird. We call that guy a potential outlier. Now remember that word potential is huge because we don't know for sure yet. Have to use potential until it's actually proven statistically that it is an outlier. So in this case, it is a potential outlier. Now with scatter plots, you can actually be a little more specific and you can actually tell me in which direction. So is this a outlier because it was farther to the left or right of the rest of the data or farther up and down from the rest of the data? And you can see this guy's an outlier because it's higher up than most of the other points. So we would say this is a potential outlier in the y direction. Now the second graph over here, very similar to that first one. It's a positive, linear, and I would actually say this is a pretty strong relationship. Now the only difference with this one is kind of these weird points over here. So this one for sure is weird, and maybe these guys, maybe this guy. But we have a few potential outliers. But now these are different because they're farther out in the x direction. So you can see that they're farther out this way to the right. So we say they're potential outliers. In the x direction. So when describing associations, describing scatter plots, direction, form, and then strength. Remember when we're talking about strength, we're talking specifically about straight lines, not curved lines. And describe any unusual features, aka outliers. Shifting and scaling, I don't want to get too much into detail with this right now. For now, all you'll need to know is that shifting and scaling any of these points, now remember these points are x and y's, right? So it's a coordinate. So if we shift and scale, it could affect either one or both of them. But what's going to happen is it's actually not going to change features of the scatter plot. And that's all I want you to know for now. So we'll not change features of scatter plot. And we'll get more into this in later chapters. All right, correlation. What is this word? This is the last thing for these notes. I'm sure you've heard that word before. So correlation we use to describe the strength of an association. So remember with strength, going back up here, we have how strong a relationship is in terms of resembling a line. So the stronger it is, the more linear of a shape it has. So correlation, in statistics, we actually have a variable for that. And we call this guy the correlation coefficient. And it is denoted by a little r. All right, and like I said, what this guy does is it describes the strength of a linear relationship. Now, every single scatter plot has a correlation coefficient. It has a number that determines, or not determines, that describes how strong that linear relationship is. Now, this number R, let's actually use a different color here. This number R is a value, and that value is restricted to any numbers between -1 and +1. Now, what does it mean to have any of these numbers? Let's actually start out with the easiest one, with +1. So if there was a association that had an R value, a correlation coefficient value of +1, what this means is that this is a strong and positive association. So what would that look like? Well, if it was at exactly 1, we can see the scatter plot resembling something of an exact line in the positive direction. So if we have an R value of +1, it's really strong and it's positive. Now on the other end, R value of -1, this is actually equally strong. The only difference is this association is in the negative direction. So if I drew a little example scatter plot down here, these points form a straight line if they were at exactly -1, and they go in the negative direction. The association is negative. So what would an R value, maybe somewhere in the middle here, be? About -0.5. Let me give you an example for this guy. Now again, -0.5, the negative tells you that the association is somewhat negative. So if I drew a scatter plot looking like this, you can tell that this association is negative. It clearly goes down. But when looking at this guy compared to the one I drew below it, this association isn't as strong. It is clearly negative, but it's not as strong as having a negative one. So this guy would be somewhere between -1 and 0. I don't know. I'm going to arbitrarily pick -0.61. We'll actually learn how to calculate that value in class, and most of the time in this course you'll actually be using your calculator to let it do all the hard work for you. Now, let's actually do that on the opposite end. Well, what having a R value of, let's say, positive 0.61. Well, since it's positive, the association is going up, but again, it's moderately strong. Not too strong, I would say moderately strong. All right, so what does this 0 mean? This 0, let's do a different color. Let's pick green. So if you have an R value, correlation coefficient value of 0, that means it is a really weak linear relationship, meaning that the association with the two variables, the scatter plot, you can't really determine any linear relationship. So kind of have random scatter like this. This would be an R value of 0, where literally it is impossible to tell if there is an association between those two variables. All right, that's it for the first part of these notes, guys. Hope this was helpful. See you guys in class.